So I'm going to go over the test review for the probability chapter, hoping that'll help everybody do better. So let's start with number 1. All radio stations in the United States have a 4-letter identification that starts with either the letter K or W. How many 4-letter identifications can be made? So we're going to start by just drawing 1, 2, 3, 4 blanks. It says the first letter has to be a K or W, so it's only 2 choices. But then the other ones can be anything. So that says 26, 26, 26. Then you're just going to multiply these together. So 2 times 26 times 26 times 26 gives you 35,152. Okay. Number 2 says a multiple choice test has 15 questions with 4 choices for each question. How many ways can the test be answered? So just like the first one, we're thinking there's like a bunch of blanks, but this time there's 15 blanks, and I'm not going to write all 15. And I have 4 choices for each one, right? So when you look and you're thinking, well, I have 4 choices 15 times, you can write that as 4 to the 15th power. So 4 to the 15th power is a really big number. It's 1073 741 824. But the idea was just we took how many choices do we have for each thing? How many things do we have? 3 is a little bit better. I said, how many ways can you toss a die 3 times? Can't count. How many ways can I toss a die 3 times? So I'm thinking I have a dice. A dice has 6 sides. So we're going to multiply 6 times 6 times 6. That's 216 ways. Hopefully you're getting this idea that it's how many ways can I do something, how many things do I have to do, and just multiplication. All right, number 4 says a restaurant offers a meal for $25. Customers pick an appetizer, an entree, and a dessert from a menu of 5 appetizers, 8 entrees, and 4 desserts. How many ways can the meal be ordered? So you have to order an appetizer, you need to get an entree, and then dessert. So 5 choices for the appetizer, 8 choices for the entree, and then finally 4 choices for the dessert. We're going to do 5 times 8 times 4. That's going to give 160. 5 says a company offers a customizable t-shirt with 40 color choices for the shirt and the same 40 colors for the lettering. How many ways can a company order t-shirts with the company name if they can't pick the same color for the lettering and the t-shirt? So let's say we had 40 choices for the t-shirt, but then I pick one. So that leaves 39 choices left. You don't want to pick the same color for the lettering in the t-shirt because then you can't see what it says. Now I have 40 times 39 is 1,560. 6 says, how many 6-digit passwords can be made if repetition is allowed? All right, so digits means I'm using the numbers 0 through 9, so there are 10 possible digits, and I'm allowed to repeat, so these 1, 2, 3, 4, 5, 6 blanks are all 10s. You could do 10 to the 6th. What's nice about that is there's just 1, 2, 3, 4, 5, 6 zeros after the 1 when we put it in the calculator, so that gives us a million choices for our password. If we change it and say, okay, you're not allowed to repeat, well then that becomes 10 times 9 times 8 times 7 times 6 times 5. So there's 1, 2, 3, 4, 5, 6 blanks, but I'm decreasing because we said not allowed to repeat. That reduces our choices a lot. Now I have 151,200 choices. 7 says a 10-sided die is rolled once. Find the probability of getting a 5. So there's one way to get a 5 out of the 10 possible choices. Okay. But what if I say you get a 5 or an 8? So now there's 2 choices out of the 10, and you want to reduce that to 1 over 5. Okay. And even, which means we're getting 2, 4, 6, 8, or 10. So there's 5 choices out of the 10 sides. That's a half. An even number or a number less than 8. Now you have 2 choices on how to do this. You could do this like mathematically through a formula, but I think sometimes you just do better if you write it all down. So I'm writing the numbers 1 through 10 at the top, and I said an even number, so let's start by circling even. 2, 4, 6, 8, 10. Or a number less than 8. So less than 8, let's also pick up 1, 3, 5, and and 7. Now when you look, 9 of the numbers are circled out of the 10 possible choices. How about if I get a number less than 12? Well, all of the numbers are less than 12, so that means we have a 100% chance of that happening. So that's 10 out of the 10, which is 1. Okay. Number 8 says you toss a coin 3 times and you have the sample space. Use the sample space to find the following probabilities. Express the answer as a fraction in lowest terms. First one says getting exactly 2 tails. So exactly is a really key word because you don't want more. So if you have 3, that's not exactly. So I'm just going to underline this is 2, this is 2, this is 2. The other ones either have 1 tail, no tails, or all tails. But I only have 3 out of the 8 that have exactly 2. And then the other one says at least 1 tail. So at least means 1 or more. So I already had those 2. Well, there's 3, so it has a tail. This has a tail. This has a tail. So does this one. Really, I only have this one, which is all heads, where I don't have a tail. So 7 out of the 8 have a tail. Okay. And number 9, let's make sure we can see our spinner. So we have a spinner that is spun once to find the probability of landing on. So the first one says positive. So I can see the numbers are -10, +8, -6, +4, and -2. So I have 1, 2, 3, 4, 5 things all together. So 5 is my denominator. And then when I look at positives, the positives are 4 and 8. So 4 is positive, 8 is positive. So I have 2 out of 5. Well, then the rest of them are negative, so that's 3 out of 5 probability of getting a negative. A number less than 4, well, a number less than 4 would be the negatives, so we're saying the same 3 out of 5 again. So less than 4 does not include 4, so you don't want to say 4 in that answer. How about a negative number or a number less than 4? Well, we kind of said that's the same. There aren't any numbers that are negative that aren't also less than 4, so we see this same probability. All right, I'm going to stop our first part here. I'm going to make multiple videos, that way none of them are too long, but I'll come back and do some more pages.